Hello everyone. In this video, we will discuss the impulse response of series RL network, the current and the voltage of the inductor when the input applied is the impulse input. So, first of all, for analyzing the circuit, whenever the impulse input is applied, transient equation is not valid. Here we have to go with the Laplace transform domain because transient equation is only valid when the input is a DC input. It should be a constant supply. So for DC input, the transient equation is valid. So that's why here the transient equation is not valid, right? And also the transient equation is not valid for the ramp input. Also for exponential input, the transient equation is not valid. For similarly for the sinusoidal input, also the transient equation is not valid. For these kind of inputs, we have to go with the Laplace transform domain. So let's draw the Laplace transform domain of the circuit. So it will be this will be R and this will be Ls and plus minus VLS, and this will be V, and the current in the circuit is ILS, right? So what is this ILS? It will be simply V upon R plus Ls, right? So for having the time domain expression, first of all we have to take this L common, right? So it will be S plus R by L. Now taking the Laplace inverse, so IL of t V by L and e raised to power minus of R by L of t. So this is the current equation, which we can see it is a standard discharging equation, right? Let's draw the waveform. This is the ILT having the maximum value, that is V by L. This is the VL of t maximum value, and for that it is exponentially decreasing like this. Right, and the time constant of this circuit is L by R. So the current value at the t is equals to time constant, it will be V by L, and this is V by L and this to power minus R by L of t. So it will be V by L and e raised to power minus 1, and e raised to power minus 1 is 0.26, 36.8%, right? It is the very known value at which the values are mostly at t is equals to time constant, which is 36.8% of the maximum value, right? This is the IL maximum. So at this time constant, which is L by R, the value is 0.368 of V by L. And now we can explain this waveform. If we want to explain just verbally, not by calculating the actual expression, we can explain this waveform of this current by जैसे यहाँ पर this input is applied at t is equals to 0, right? Impulse input, right? अब impulse में आपको पता होना चाहिए कि impulse का जो magnitude होता है वो हमेशा infinite होता है, right? But area finite होता है. Area तो यहाँ पर v है, but magnitude infinite है. So what does it mean कि एक infinite magnitude का voltage we have applied on this RL network. So यहाँ इसमें जो current है circuit का वो basically because input 0 टाइम पे अप्लाई हुआ है t इक्वल टू 0 पे, तो t इज इक्वल टू 0 पर ही जो करंट है सर्किट का वो इंस्टेंटेनियसली उसकी मैक्सिमम वैल्यू को शूट अप करेगा, राइट? और बिकॉज इनपुट केवल 0 टाइम पे अप्लाइड है, यहाँ तो इनपुट में नहीं, राइट? ओनली 0 टाइम पर अप्लाइड है, तो उसके बाद ही सर्किट एक डिस्चार्जिंग नेटवर्क बन जाएगा. तो इसलिए उसकी मैक्सिमम वैल्यू से जस्ट एक तरह से डिक्लाइन होता हो करंट 0 हो जाएगा, राइट? सो यहाँ पर व्हाट इज द इंटरेस्टिंग थिंग इज दैट कि यहाँ पर we can say this is the discontinuity, right? The initial current यहाँ पर जो IL0 minus was 0 ampere, but IL0 plus is not 0 ampere. What does this mean? That inductor is violating its own property, because inductor का ये property होता है कि inductor hold करता है current को, but we can see here because of this discontinuity, inductor is not following his own property. So this is a very good point. So whenever Input is an impulse input on a series RL network. Inductor violates its own property and IL0 minus is not equal to IL0 plus. So this is very good concept. Now for the voltage of this inductor, so VLS in the transform domain only, first of all. So by we can this solve this expression by VDS, right? So it will be V into Ls upon R plus Ls. So it will be V into Ls upon R plus Ls. Again, we have to take the L common from here. It will be cancelled out. So it will be Vs upon R S plus R by L. Now for having the time domain expression, first of all, we have to adjust this numerator, adding this R by L and subtracting this R by L, right? And यहाँ पर this will be R plus R by L. So it will be then 1 minus R by L upon S plus R by L. So this is the VLS. Now taking the Laplace inverse. So VL of t will be V. Now Laplace inverse of 1 will be impulse, right, delta t, and minus R by L and exponential raised to power minus of R by L of t. So this is the voltage equation for this impulse input, right? Now another method for the voltage, so we can directly go with the time domain form. So VLT is equals to L didt, right? And ILT is equals to V by L and exponential raised to power minus of R by LT. Now, so VLT according to this will be L and this V by L will be common, right? And derivative of this, that is minus R by L and exponential raised to power minus R by LT. So if we have solved like this, so this is absolutely wrong. Why it is wrong? अब यहाँ पर करंट का इक्वेशन अपन लिख कैसे लेते हैं, वी बाय एल वी टू माइनस आर बाय टी, बट यहाँ पर ये नहीं भूलना है कि यहाँ पर एक यूनिट स्टेप, बिकॉज ये तो जब आपने लाप्लास इनवर्स लिया था तो यहाँ यूनिट स्टेप भी आता है, ये अपन लिखते नहीं है बट पता होना चाहिए कि यूनिट स्टेप है, बिकॉज यहाँ पर डेरिवेटिव करने का नीड, तो दिस यूनिट स्टेप कांट वी कांट इग्नोर दिस यूनिट स्टेप हियर. सो दिस इज वेरी मच टेकन केयर ऑफ दिस पॉइंट्स कि VL जब अपन लिखेंगे तो यहाँ पर इस तरह से होगा VL, this is L and this will be V by L will be common and d by dt of e is to the power minus of R by L t and ut. तो इस तरह से इसका डेरिवेटिव होगा. This is the first or second or whatever sequence. So this will be exponential raised to minus R by L t, then इसका derivative will be delta t, then plus ut will be as it is, then it will be minus R by L and e raised to power minus of R by L of t, right? So this is the voltage waveform. So this should be very much clear that we can't ignore this ut problem, right? So this is the analysis and I hope it is clear. So okay, thank you.